Hello everyone, I'm Akshay from Merkle Science. I have been at Merkle Science for about 4 years, and with me is Priyanshu. I lead the data engineering team, and Priyanshu is my colleague there. We'll go about what is Merkle Science, what we do. So we are a blockchain analytics and compliance company. We provide four tools to our customers: Compass, Tracker, KYBB, and Institute. So Compass, first of all, who we work with. So we work with crypto businesses, financial institutions, law enforcement agencies, and regulators. So Compass is a transaction screening and wallet monitoring. So who are like people who are not aware with the term wallet, wallet is same as bank account number that you have. So we help with the compliance, like figuring out anti-money laundering and regulatory compliances for our customers. Next, we have Tracker. This is a comprehensive investigation tool. This helps you visualize the flow of funds within the UI in the form of graphs. Next, we have KYBB. KYBB stands for Know Your Blockchain Business. So this is on-chain analytics coupled with off-chain and off-chain. So on-chain and off-chain. On-chain is the blockchain data. Off-chain is like the data, metadata about the company, like where the company is registered, whether they are KYC compliant, things like that. So we enrich it, and this is an aggregated data sets. So first, we'll give a brief demo of what exactly our products are. So we go through Compass and Tracker. So on Tracker, we have a coin DCX hack, which is more relatable to us. So yeah, this is Compass. So on the left side of the panel, you can see the details about this particular wallet. So we know this is a scam address. So this person, like this wallet belongs to a entity who has done some scam. On the right side, you can see all the tokens he has done transactions with, or the total incoming, total outgoing about that token. And just below it, you can see so we can configure rules and alerts on our platform. So as soon as you like screen an address, you can see what all alerts it has triggered based on the rules set on the platform. So can you go down? So like below so this is the direct information. Now we have multi-hop analysis. So this is like how like not just direct, like if I'm sending funds to address B, I'm not just concerned about the exposure to the B, I am also concerned who he is sending to funds. So we can go on about 25 hops. That is the limit on the product Compass. Like 25 hops, we can calculate the exposure of that address. So here you can see like we have direct exposures of this address and also the indirect. So indirect is the multi-hop thing that we talked about. So next we will show you Tracker. So this is the visualization tool that we were talking about. This is a purely graphical visualization tool. So this is actually a hack track. So how the coin D6 funds exploit happened. So it started all with this center graph. Can you zoom to the address? So if you look at this particular address, so this was the address on the Solana blockchain of the coin DCX, which got exploited. And how the funds move from this address, we have all the analysis. We can visualize everything from this graph. So we know from Solana blockchain, it all went to this Mayan Finance, which is a cross-chain bridge. So after that point, we know it moved to Ethereum. So here we can see that how all the funds it went through multiple hops and it finally get consolidated to this one particular address. So we have this all hack track where you can see how the funds are moving, and like we can actually this helps law enforcement agencies to figure out what exactly, when we say 10% exposure to illegal activity, what illegal activity it is, what amount of transactions, and what exact transactions. So talking about why we use ClickHouse. So first of all, to understand why we use ClickHouse, we need to understand what is the data that we work with. So we have blockchain data. Blockchain data is purely transactional data. It is completely immutable. We need to store everything. So like starting from the initial block 0, till the recent time, and even real time. We need to store real time data as soon as a transaction is submitted on the blockchain, we need to make sure it reaches our platform. And currently, with Kafka integration, that is somewhere around 3 to 5 seconds. As soon as a transaction is submitted on the chain and it gets to our platform, it's available for real time screening. And apart from this, we have attribution data. So we showed you that that particular wallet was a scam address. So that is a dimension of that data. So this is something which can change over the time. And apart from this, we also have clustering. So we have heuristics which can cluster the group of addresses. So for a fact, we know Binance has 86 million wallets from our clustering. So it's something which can keep on changing, and it's something which will keep on evolving over the time. And so our requirements with the database. So our use case is point lookups. We need point lookups for a transaction, point lookups for a address. So we need to make sure it is very fast. It has to be very, very low latency. Like our clients want to block the transactions as soon as it, if they know if it is with an actor which has got any kind of illegal activity, they would like to block it as soon as possible. We want fast aggregates on our data sets, because we are going to be crunching about billion rows if it's required. So on an average, we can scan petabytes of data every day. So we need something which can work at that scale. So this is where ClickHouse actually sits very well for us. Next, we needed something which has open source integrations, because we would be working with a lot of things outside the ClickHouse, like Kafka, Databricks, and other lakehouse formats. And also, it has to be scalable. We know that for a fact that ClickHouse can scale both horizontally and vertically. So this is something which actually fits in very well with our use case. And most of all, it should be cost efficient. It should not be something which is burning a hole in our whole tech budget. So our ClickHouse journey. So I will be talking about we did 3 major overhauls in our ClickHouse history. So when we started the company itself. So we were at version 19. So those who are aware with the ClickHouse versions, it's the year that is the version of the ClickHouse. So we were at version 19, and at that time we had only 6 blockchains. This is the time I had joined the company, and in 2022 we did a first schema upgrade and overhaul. So we were using a lot of inefficient engines like collapsing engines and other engines. They have a particular limitation where you can use it. So we got rid of them, and then we moved to version 21. So that time, since we were at 6 blockchains, everything was working fine. Then again in 2023, we had already reached around 11 blockchains, and things were not scaling as we were expecting. So this is when we did a complete architecture overhaul. We changed entire schemas, we introduced aggregates tables, pre-aggregates, and everything. So this is when we were at around 8 to 10 dB of data, and at that time after that it has been very stable for us. The right use of dictionaries, the right use of materialized views has given us that confidence that we could actually scale things very well. Then in 2024 is when we started evaluating ClickHouse Cloud for us for our use case. So at that point, and even now, our team is we have only 3 data engineers and 1 DevOps engineer, and it's very hard for us to actually manage all this infrastructure along with the blockchain nodes. So this is when we started moving to ClickHouse Cloud, and at that time, our economics of using self-hosted ClickHouse versus ClickHouse Cloud was actually same. But we saw how much easier it was, because since we moved to ClickHouse Cloud, we never had to actually worry about scaling. And since then, we have actually added to 10 more blockchains. And right now we are actually processing, storing 80 dB of compressed data on ClickHouse, and with 25 blockchains. And everything is real time with no issues, nothing. So this is something now. Earlier, before 2024, we were more focused on making sure that our infra is always up. We don't go down. It doesn't impact our customers. But since then, since we migrated, we never had to worry actually about any of that, and we are actually shipping more features than we could before. So I'll let Priyanshu talk more about the technical aspects of how we do things.
Hi, good afternoon, everyone. I am Priyanshu Sehgal. I'm working as a senior data engineer at Merkle Science. So before we dig into the ClickHouse architecture, that how we migrated from on-prem ClickHouse to ClickHouse Cloud, I'll first just give you an overview, a black box overview, like how data moves in Merkle Science. So for analyzing the whole crypto chains, right, blockchain nodes, blockchain data, the very first step is extracting the data from the blockchain nodes, that is the transactions, traces, and the blocks metadata that we extract. And there are two layers then, the batch layer and the streaming layer. The first, the data is pushed to the streaming layer. We push the data, raw data, to Kafka, and then we have the Python processors that are deployed on Kubernetes pods. So it's horizontally scalable. We do pre-processing and transformations on all the 25 chains that we support. And then we push again to Kafka, and then it moves to ClickHouse. In the batch layer, there are like complex processing and transformations, clustering, balance transformations, everything that is done in batch. That depends on the chain. Is it hourly or daily? That our batch layer is deployed on Airflow. So we orchestrate all our pipelines via Airflow. We trigger database jobs and then do clustering and then do all the processing and transformations. Now, how the data moves to ClickHouse on a knowledge graph is like from streaming layer to ClickHouse. We use the Kafka engine in ClickHouse, and we are still testing the Click pipes. And once we are tested and satisfied with the results, we'll move to the migrate to Click pipes. Currently, we are using Kafka engine. And for the batch layer, we just export to GCS and packet files to ClickHouse. That is like parallel loading into ClickHouse using the S3 engine. And similarly in the graph database. So for us, graph database and ClickHouse act as the major prime databases which deliver the queries, which deliver the data to our product. We have two products, as Akshay explained, Compass and Tracker. So they just query ClickHouse and the graph databases to give the end users the output. So to give you an overview of how much data we use, right, how much data flows through these pipelines, I'll give you an example of Solana. So Solana raw data is like 600 TB. So 600 TB goes to batch layers. That is like the whole overall data size of Solana chain. It goes to the batch layer and then to ClickHouse. So after processing batch layer to a data warehouse, it compresses to 200 TB. And till the time it reaches ClickHouse, it is compressed even more. So for all our 25 blockchains, the whole data that we have in ClickHouse is around 200 terabytes. So if I give you an overview, like how much time we take, like as Akshay also mentioned, so as soon as a transaction is published on the blockchain, it takes around 6 seconds for us to process it by streaming and then pushing it into Kafka and then pushing it into ClickHouse. Overall, it's 6 seconds. And our Compass and Tracker queries then ClickHouse in our knowledge graph in less than 200 milliseconds. Coming towards the ClickHouse architecture that we had on-prem, previously we used one ClickHouse cluster in V21 version that had like 4 ClickHouse nodes. Each node, as you can see, will have two shards, one primary and one replica. And let's say that ClickHouse node 1 is having the primary shard itself and the replica of ClickHouse node 4 as the colors are mentioned. Similarly, node 2, 3 and 4 will have in the same manner. And we had Zookeeper deployed that did the merges in ClickHouse, manages the metadata and everything for us. And in this architecture, we faced a lot of issues. So the first issue was the sharding. As we scaled from 8 blockchains to 11 blockchains, the sharding keys and in 2021, the volume of blockchain also transactions also increased on the blockchains. So the main issue we were facing was sharding. So it was getting slow in writing and slow in reading. So we moved to a newer architecture that was V23. I don't have a slide for that, but I'll explain you an overall picture of that. So in V23, we removed sharding as an overall feature. And we just made, this is one cluster, we made 4 clusters. Each cluster will have again one primary and one replica. And then again, we have 3 zookeepers that used to manage the metadata and the mergers and everything in ClickHouse. And again in V23, we were facing a lot of issues. Since Akshay mentioned, right, we have a lean team. So most of the times we were spending was on babysitting the processes, like if our infra goes down, if we have to do a large chunk of inserts in the ClickHouse, it takes a lot of time for a team. Like, it's a waste of time for software engineers, right, for doing the repeatable works. So we were looking for options, and then we came across ClickHouse Cloud. So ClickHouse Cloud gives us a lot of good features and solves a lot of our problems. So the major problem that is solved was the infrastructure management. Now we don't have to manage the infrastructure. Everything is managed by ClickHouse Cloud. The next thing was the disk anxiety, right? So we had to manually increase the disk sizes. We have to manually, if we have to add a new blockchain, like Solana, let's say. So we'll have to increase the disk size manually and then ingest the data into that. And there was no parallel ingestions in our previously in on-prem ClickHouse. So disk anxiety was removed. So everything was put into ClickHouse object storage, and even it provides the parallel insertions by S3 engine. So it was very quick for us to load data, ingest data, and move it into production. Another issue that we faced with our on-prem ClickHouse was lack of support. So anytime our product goes down, right? So we don't have support. It's an open source platform. We have to read articles. We have to see things like how to bring the systems up. With ClickHouse Cloud, currently we are at 99.99 uptime. So that helps a lot for us. And then it was scaling. Like I already mentioned, a lot of problems came with scaling. So as soon as the traffic increased from as we are expecting, the systems starts failing, right? Start failing to give the output to the queries. So that's how we have auto scaling in ClickHouse that works best. The main thing that if you have used a lot of databases, right? So you will know that if we are using SSD disks, so we are reading from the same SSD disk and writing to the same SSD disk. So there is a degradation in performance in read and write both. So with the new feature of ClickHouse Cloud, right, compute separation, we have gained a lot of optimizations and improve in performance. So we have, let's say, 2 clusters in compute clusters in ClickHouse Cloud. One is for writing and one is for reading. So it's a small cluster of writing and it's a huge cluster of reading that we use, and that helps us a lot. Even the compute cluster helps us to move from dev to prod. So let's say we are adding a new blockchain. We'll first push the data into object storage in ClickHouse, then spin up a dev cluster, test it out, and then move it into production. And also, we don't have to care about the version upgrades. Like ClickHouse Cloud automatically gives us the version upgrades. Now coming to the business outcomes. So there were a lot of challenges that we faced previously, as I told. So with business outcomes, coming to business outcomes, there is we do a lot of built-in aggregation and real-time processing, right? As I explained in batch and streaming layer. So the thing with built-in aggregation is we use replicated merge trees and we use replicated aggregating merge trees. So after pushing the data into replicated merge trees, we use materialized views, and then it is aggregated and is given to the client. So with this format, previously we were facing a lot of issues with analytic queries running in the background, merges running in the background, and in the on-prem ClickHouse, it with read and write separated, right? It helps a lot in background merges and faster aggregations in the background also. Now coming to the real-time behavior rules we have for fraud detection. As Akshay showed you, right, we have alerts in our product. So with that alerts, we can generate, we can analyze the whole blockchain and see some patterns, right, like behavior rules. To give you an example, like a few days back, there was a huge case in crypto. Some hacker tried to hack US link tokens. It was around 542 million tokens, and which was worth around tens of millions of dollars. They tried to hack it and transfer it to some wallet. But with our real-time aggregation and real-time behavior rules, we stopped it, and the agencies used it and blocked the 3 transactions that were responsible for transferring the funds. So it was really helpful for them to block the transactions and stop this hack. I have explained the faster dev to prod migration. That is a real boon for the team. And coming to the data size, like we provide to our clients and less up with so much data volume, we still are able to process the whole data and give the P99 is still remains less than 200 milliseconds. And we do normally around 5 million plus selects per day, scanning petabytes of data. So what's next with ClickHouse and Merkle brings us to, like, we are still facing a lot of issues with the aggregation engines, right? So let's say, as Akshay mentioned, Binance has around 86 million wallets. That turns around into 3.5 billion transactions in those wallets. And if our product needs to query those kind of transactions and give you an aggregated sum of all the wallets and transactions, it's really hard to do it in ClickHouse. So the solution was projections, since materialized views are only for insert only. So we are using projections. It helps us to pre-aggregate the data group on billions of rows and again provide to our product in less than our ideal time. Then the next step we are trying to use is substring search with ClickHouse. So let's say any user wants to search a wallet, search a transaction ID, but he or she doesn't know the exact transaction hash. So he or she just can put in the search bar the substring of that transaction hash, and will help to find the search and give them the ideal transaction hash and address wallets. Another example that is coming to my mind was another query came to us from Consensus a month back. That was like screening 200 million addresses on our platform for linear chain. So we did that in like ideal time. We were not expecting. We gave product that it will be done in 15 to 16 hours, but our ClickHouse Cloud auto scaled and it performed and it will, and the result was coming in around 8 hours. So that's how all our auto scalable pipelines basically works. So coming to the AI chatbot prototype. So this is where basically, if you have seen our products, right? So you need a basic knowledge of how funds move in crypto, right? So you will have to know how funds are moving from one address to another, one wallet to another. So that needs a little bit of expertise to use our platforms. With the coming of LLMs and improvement in those, it gives us a boon and increase our client base with the use of this prototype. And we have built it using the ClickHouse MPC, and we'll show you how it works. So basically, you can just use normal language, like analyze an Ethereum address you have, and it will just use the ClickHouse MPC, our data in the background, and then it will start to give you the details that you saw in Compass and Tracker. You will see which this address was active on which chains, what are the address balances on which tokens, and all the details that we have for this address, all using the simple queries, not SQL, not anything fancy, just simple natural language. So this will give you all the details that we showed you using the tracker and ClickHouse tracker and Compass demo, right? So this we are still building, and mostly it will be done in some time, and it will be a very good feature to add to our product. So that's it from our side, and so we are hiring. And as our data increases, as we add more blockchains, we need more data folks. Anyone who is interested should can ping on this email, and we'll be happy to work with you guys. Yeah, thank you.
Thank you.